Yeah, thank you very much.
Pleasure. All right. Our next speaker is no stranger to this community. He's one of the first people that actually started talking to when I joined the community as community leader last year. His name is Álvaro Hernández. He is the CEO and founder of Postgres. And if you ever, and I mean ever, have any question that's related to Postgres, whether it's on Kubernetes or outside Kubernetes, obviously for our community's sake, inside Kubernetes, Álvaro has been an amazing presenter. I'm looking forward to having him in a talk as well in Spanish at some point. One of the best attended meetups, possibly the best attended meetup. I think it was the best attended meetup that we had, was given by Álvaro earlier a few months ago. So anyway, wonderful to have you back with us today. We've got a few minutes. We got 15 minutes. So Álvaro, let's jump right in.
All right. Thank you so much for having me here today. And let's get into it. I have a quick presentation here today about why you should be deploying Postgres primarily on Kubernetes. So are we ready to go?
Yep, you're good.
Excellent. All right, so first of all, let's start talking about deploying Postgres without Kubernetes. What basically you need to do to get Postgres up and running without using Kubernetes, old school, as we were all doing a few years ago, right? So what it takes, what it's gonna take to get up and running. So it's actually pretty simple, right? If you're using Ubuntu or Debian distribution or something like that, you can just apt-get install PostgreSQL and you're done. This operation will run in about 40 seconds, depending on your internet connection, and you'll get a Postgres cluster up and running. So I guess this presentation is pretty much over because we just say at this point, don't run Postgres on Kubernetes. This is so simple that why even worry? Why even have to deal with other areas, right? Because Kubernetes is complex, right? Well, that's what some people say. So we're done. Presentation is finished. Let's go to the questions. Or not really. In reality, there's a few small caveats here. The first one is pretty technical, but basically, you may not get the latest version of Postgres by issuing this command. You may want to add some other repositories with more newer versions of Postgres. And probably if you're using a Red Hat environment or based distribution, you're going to run different commands. You need to type a few more commands there. But other than these technicalities, you will not get a Postgres that is totally ready for production usage. And that's the key here. If you're running just for testing on your laptop, you're probably fine with this. But if you're going to deploy this into production, you may need to do some tweaking. The first one is going to be configuration. So let's talk about configuration. We really need to tune the database to run Postgres in production. If you take Postgres configuration as it comes by default, it's super conservative. It is great for running on a Raspberry Pi cluster, which I heard someone has a cluster around. So maybe that's fine for a Raspberry Pi. But in reality, when you're going to run Postgres on a 96 core machine with 600 gigabytes of RAM and several terabytes of stored SSD disk, you want to tune some basic Postgres parameters. I'm not even saying like, let's go super deep on this, but at least a basic tuning you really need to apply to Postgres. Just to give you a hint, Postgres by default comes with 128 megabytes of shared buffers. Shared buffers is the parameter that controls the caching you do in RAM. So basically, if you don't tune Postgres by default, you're going to be using 128 megabytes of RAM. As I said, that's probably good for Raspberry Pi, but not for your production cluster. You probably want to cache more in RAM. I mean, Postgres will run fine with it. It's like if you have a Ferrari and you're running just on first gear. You'll get quite good speed, but not the one you're expecting, right? So this is the same case. Even if you just look at the default configuration, will not be open to the world. Postgres will only be listening on localhost. So you definitely need to tune Postgres. And this is no easy task. So to tune Postgres contains almost 300 tunable parameters. And some of them require quite a significant amount of Postgres expertise to tune. So even if we're just aiming at the basic tuning, just getting some basic parameters, letting Postgres connect to the outside world, having a decent sizing of memory RAM, some of the other parameters that affect query performance, like word mem, the amount of parallel processes that you want to run, some basic tuning for logging, which is later on critical for actually troubleshooting performance problems, you need to involve quite a fair amount of time. Let's say a Postgres DBA with a semi-experienced to experienced may require 2 to 8 hours to perform this job. This is a wild estimate. Of course, if you're going to do a deep tuning, you really require much more time for this. You probably require to run benchmarks, to verify the performance assumptions that you're making, and so forth. If you're wondering, this small help, there's an online tool that, disclaimer, I helped build it, called PostgreSQL call.nf. It's just like the PostgreSQL conf file, except that you're moving the dot 2 positions to the right. So PostgreSQL call.nf, it allows you to upload a Postgres config, interact with an API, download, store them. It's like your GitHub repo for PostgreSQL.confs, and comes with a tuning guide. So this may help you in the process. But okay, so fair enough. We need to install Postgres. That was easy. Then we need to tune Postgres. This requires a little bit more expertise, and we need a Postgres DBA for this. What else? Are we ready to go live? Well, not really, because in reality, if you look at Postgres, Postgres always require, or almost always, let's be precise, requires connection pooling. If you just deploy Postgres to the outside world without connection pooling, very likely you're going to run into trouble. Which kind of trouble? So basically, here there's a small benchmark that I ran where comparing Postgres on a small instance, because the defect shows earlier, where if you just increase the amount of parallel connections hitting Postgres, let's up to 500 in this case. So let's say you want to have 500 concurrent users. The performance of the database in terms of transactions per second is okay, kind of slightly even grows. But when you look at the latency, the time you're taking to serve these queries, it's terrible. It basically dramatically skyrockets. In order to run Postgres and solve these performance problems you may experience with a high amount of concurrent connections, you typically always need connection pooling. And connection pooling can be fronting the database, can be set up as a middleware layer, can be on the client side, can be on all of them, or a combination of those elements. And it takes time to understand where you want this connection pooling to be fronting the database, which position the architecture, how to tune it, whether you're going to run in session mode or transaction mode. There's a few tunables there. So you're going to require, under my estimation, some amount of time to set this up. It's pretty usual, so you don't need a lot of time still, but you require help from a, let's say, DevOps profile and also a Postgres DBA profile, because you need some Postgres expertise also here, something in between 4 to 16 hours for the optimistic case, 16 hours, a more potentially realistic case. So, okay, so we need to do tuning, we need to do connection pooling. Is there anything else we need to do to deploy a Postgres stack in production? Well, yes, because who doesn't want high availability as of today, right? Do you want to be woken up at 3 a.m. in the morning? I don't. And I want to have my servers, my Postgres nodes to do automatic failover. I want them to reconnect automatically. I probably even want to have them, if a node fails, to be reprovisioned automatically. And I'm not even getting into that, because you can also do that outside of Kubernetes, even though it's quite trivial on Kubernetes. It could also be easy to do somehow with some auto-scaling mechanism on cloud environments and so forth, harder to do on-prem. But even without doing that, setting up high availability in Postgres is pretty tough. You need to first select the software you're going to use for this. For example, Patroni, in case of Postgres, one of the most recommended software for high availability, or PG auto failover. But then you need to solve all the pain points related to high availability. You need to talk about how to distribute the Postgres configuration so that it's uniform across all the servers in the fleet. And you need to solve the entry point problem, which is how I'm going to locate the master. Is going to be via DNS, virtual IP. I'm going to do some other discovery mechanisms. So in reality, setting something like this will take you probably from 8 to 24 hours of a mixed profile, again, something like a DevOps person and some Postgres expertise required anyway. And of course, who doesn't want backups, right? We need backups to also deploy Postgres in production. So the same story applies here. And to solve the backup problem, I need to understand which tool I'm going to use, where I'm going to store the backups, how I'm going to perform lifecycle management for those backups, how to recycle, rotate them, and obviously to talk about restoration and testing of backups. In this case, not much Postgres expertise is required. A simple Postgres tool like WebGL or PG Backrest, anyone without Postgres expertise and DevOps profile would probably be able to set it up in something like 4 to 16 hours time. But of course, we want monitoring, doesn't it? We want to use something like Grafana for monitoring Postgres. And this is also quite involved because Postgres computationally exposes a lot of metrics, but you need to write queries for those. So some tools, of course, come with this queries pre-configured, but you will probably want to customize them. So you're going to need, again, a combination of DevOps and Postgres DBAs to sort this out and be able to export the metrics you want to Prometheus. So let's say this is going to take anywhere between 8 and 24 hours of work. And in reality, just imagine a 12-node Postgres server. Are you going to leave the logs of each Postgres server on each node? Probably not. You want to send them to a central location where you can process them together and help them troubleshoot. So this takes something like export to CSV logging, use an agent collector like FluentBeat, implement a collector like FluentD, or just send them to a SaaS service where you're going to be paying for that. But in that case, I will tell you something like 4 hours for reading doc and setting it up. Otherwise, if we're going to doing the FluentD setup and CSV logging, it's going to take you like maybe 4 days of work. This DevOps can do, but still some work. And if you want to run some more advanced use cases, for example, right now, you could use Envoy for proxying the Postgres traffic. This comes with mainly 2 significant advantages. One is that you can export additional metrics of the network layer to Prometheus, something like Prometheus. The other one is that you can offload SSL starting with Envoy 1.18. So relieving Postgres of managing SSL rotating certificates and so forth. There's an interesting blog post that is linked here about how to use Envoy with Postgres, and this is a recommended setup. So this would also take something around 8 to 16 hours for DevOps. Envoy configuration is not easy. Envoy is a great software configuration, requires a little bit of expertise. And what about managing all the cluster? Here, there's a lot of question marks. Yes, because there's basically no software for managing Postgres clusters. There is for managing Postgres databases, but not clusters. So this will take an indefinite amount of time to build or set up a tool to help you manage several clusters, not just one. And last but not least, you probably want to automate all this. So you want to run all this via IIC or infrastructure as code, and this will take a lot of time. Just bear in mind all the tools and all the components of this stack that we have mentioned that you need to set up an enterprise-grade Postgres stack. So anywhere between 48 and 96 hours of DevOps work, and this is probably pretty conservative. So just in summary, this is all the components that you probably need to run a Postgres stack in production. Let's look now at how we would deploy this in Kubernetes. Well, type this. This simple YAML will give you a Postgres cluster on Kubernetes with connection pooling, with tuned config by default, and a few other bells and whistles there. So just 1 hour of a Kubernetes administrator would suffice. In reality, you probably need a little bit more, right? I'm here. This CRD, by the way, is an example software I'm using to illustrate these principles called Postgres. If you want to have more information about it, just go to postgres.io. And this is a Postgres operator on Kubernetes, which implements all the features that I'm using here. That's why I'm using here as an example. And so this simple YAML file will create a cluster. If you really want a few more bells and whistles, like automatic backups, like Envoy proxying and integrated monitoring, you probably need a few more lines of YAML, but it's not more that it's going to take anywhere between 4 to 16 hours of a Kubernetes administrator. But know that not all the DevOps knowledge or especially Postgres knowledge is going to be needed. It comes with default tuning config and all the components that I just mentioned before. So you may spend some additional hours to create ingress if that's needed, to expose the web console through load balancer, or just integrate with DevOps. So let's say in total, you're going to do a really good job by investing anywhere between 4 and 16 hours of a Kubernetes administrator, not Postgres expertise required job. So in summary, if we want to compare what it's going to take this in total, we're looking at a significant comparison that goes from up to 300 hours of work with just 16 hours of work in the worst case for both scenarios, comparing solutions on Kubernetes or not Kubernetes. What about day 2 operations? Once I have deployed the cluster, I may want to run database administration tasks. And there are several of those which are automated in Postgres operators like the one that I mentioned, Postgres, like repack, vacuum, running major version upgrades, minor version upgrades, controlled restarts, even benchmarks. They're all automated with a few lines of YAML. How much time are all those efforts going to take you without Kubernetes? So those are all the reasons on why to deploy Postgres on Kubernetes. Briefly mentioning what's the reasons not to deploy Postgres on Kubernetes. So option number 1, if you just want to run a fully managed service, something like RDS, and really pay for it because the price difference is significant, then you should go that route. The other option is if you need specific OS tuning software or some specific capabilities like CFS, which sometimes are released on some particular Kubernetes environments, then you probably want to stay there. The last option that I really can think of is that if you think the Earth is flat, the vaccines don't work, and Kubernetes is not for data storage or data platforms, then if you don't want to get out of your comfort zone, then stay there. There's not much we can do. So that's pretty much what I wanted to share with you today. I don't know if we have some questions.
Yes, we do. And it's no surprise that we do, Álvaro, because that was a fantastic presentation in a very short period of time. Let's take a look really quickly at some of the questions that we got. So from the Panda Guitar, who's been one of our most active members in the YouTube chat. So correct me if I'm wrong, but Postgres is a single code relational database. But to have PG be compatible with Kubernetes, wouldn't that need some fundamental changes?
Actually, yes, and that's part of the effort that we are trying to leverage at the StackRest project. The previous talk that I gave at the Data on Kubernetes meetup, which I would suggest you to have a look at, is recorded on video. It's called Deconstructing Postgres as a cloud-native platform. And precisely the goal of this is to try to strip off some parts of Postgres which can be offloaded to other components of the cloud-native ecosystem, like Envoy that I mentioned, like Fluentd, obviously Grafana for monitoring. And we, as time passes by and we're innovating here, we're taking off some parts of Postgres functionality and offloading to these components. So it feels A, more natural for Kubernetes administrators, and B, we're simplifying the Postgres core component by itself.
Very good. What I'm going to do right now is I'm going to link that here in the chat for any folks that want to take it out, take a look. I really liked the references to vaccines. That was great too. 5G, of course. So let's see what else we got, because yeah, there was a follow-up on that about saying how Postgres has many high availability options, which you would definitely want on Kubernetes. So yeah, so just following up with exactly what you mentioned there. That's great. I guess, can we maybe just really quickly, I mean, we're about to take our break, but you know, when folks are looking at some of the alternatives that are out there in terms of which database they should be thinking about, you know, you have mentioned this before, I'm sure more than a couple of times, but we're looking at the Kubernetes spectrum, right? What is it that Postgres provides that we just cannot find in another database?
Well, there's really, really many things. Postgres is an extremely featureful database. And the first thing I would say is feature set. Most people use databases in a limited fashion, and that's okay. But if you really want to dive deeper into what Postgres can offer, like the SQL compatibility layer, I'll give you one quick sample. A few years ago, almost nobody knew about recursive queries, for example. And recursive queries, just that feature by itself alone, helped discuss the common platform, switch some query rendering on a page but to a version that took 20 times less effort in terms of CPU usage to run. So comments were loading 20 times faster on the node, and that's because a comment, you know, is kind of a hierarchy like the tree structure. And instead of throwing many queries to the database, you're just throwing one, which is the recursive query. So if you really look at all the features that Postgres comes with, and you really exploit that, you're going to get a really, really powerful database. And not many other databases have this same level of features. The other one that I would say is extensions. Postgres has an extension mechanism like plugins, and you can really extend to your will by creating or using already available extensions. And that kind of transforms the database. Think of Firefox plugins or Chrome plugins. It's the same idea, except for your data.
All right, perfect, good. We got a couple follow-up questions on that too. What about sharding provided by CDSDB?
Yeah, Citus. Yeah.
Sorry. Excuse me.
Yeah, just to make sure. So, Postgres is designed initially as a single cluster database, right? Like one primary and several replicas. Even though you can do cascading and you can create some complex topologies in terms of replication, also supports logical replication. Sharding is not built in, but Citus is a great example of one of those extensions that I was mentioning. And Citus enables Postgres to become a sharded database. It's a great solution for you on sharding, and you have data that supports a good distribution. You can distribute data according to a sharding criteria that is optimal for distribution, and it works great. As for Citus on Kubernetes, I believe there's way to go. The Microsoft team who acquired Citus some time ago, I know they're developing solutions for running Citus in the cloud in Azure. And I believe there's also already in beta preview a solution for running Citus also on Kubernetes. But anyway, this is open source, is AGPL3, so we can expect to be in other open source solutions anytime soon.
Good. Let's see. Any opinions about Supabase?
Oh yeah, I like the idea. I like the project. It's a way to expose Postgres in a different way with a different kind of API, more application towards oriented. And I just have nice words for the project. I think it's a cool project.
Okay, good. Yeah, because we got some comments in there. Because yeah, someone said they were also tinkering with that. It's basically hosted Postgres with subscription feature to make it work like Firebase. Hasn't tried self-hosting yet. Anyway, great stuff, Álvaro. Someone was asking as well too about a link to the amazing talk that you give us in the meetup previously. So we linked that there. Definitely check that out. Álvaro's got a lot of resources out there. It gives a lot of talks. Very, very active in the Postgres community. Also has a Postgres foundation that he started. So we'll probably link that as well too here. That being said, Álvaro, thank you very, very much. We're going to take a quick break. All right, we're going to take a 15-minute break. We'll be back in 15